Today's problem is minimize the heights. 2. Difficulty medium, given an array denoting heights of n towers and a positive integer k. For each tower, you must perform exactly one of the following operations exactly once. Increase the height of the tower by k, or decrease the height of the tower by k. Find the minimum possible difference between the height of the shortest and tallest towers after you have modified each tower. You can find a slight modification of the problem here. Okay, yeah, spoiler alert, that is minimize the heights 1. And really, the only difference, I think, is that, well, let's read the note here. It is compulsory to increase or decrease the height by k for each tower. After the operation, the resultant array should not contain any negative integers. Now, I don't think that's a requirement. I don't think that's a constraint for version 1. So what that means is if you did version 1 and you just took this out where we're checking for negative integers, then it should be the same problem. Okay, well, let's look at constraints, then we'll look at examples. K is between 1 and 10 to the 7th. What is that? 7 zeros. 10 million. Number of towers is between 1 and 10 to the 5th. 100,000. The array elements are between 1 and 10 million. Expected complexities, n log n. So there's a sort in here. Companies, Microsoft, Adobe, topic tags, greedy. Let's see. In what way is this? I guess so. Now we're just looking for optimal results at each decision point. So let's scoot this over a little bit. And actually, I want to be able to see the second example here. That's what we're going to use. I don't have enough room there. But k is 3. Let's just remember that k is 3. And move it over so we can still see the array. All right. That should be fine. Let's get a pen. I'm going to write down 3 here. K is 3. All right. Array length, sort the array. These examples, they're already sorted, but there's nothing in the problem description that says guaranteed these things are going to be sorted. Actually, there's one thing that I want to call out here before we start working on it, and that is basically what we want to do is we want to make the smaller numbers bigger, and we want to make the bigger numbers smaller. But where is the break point there? But we want to add k to the smaller numbers and subtract k from the larger numbers. And as I say, we have to find some appropriate switch point to get the best answer. And there may be more than one switch point. But as long as we pick one, we're okay. So there's some point at which we're going to stop adding k to these numbers and start subtracting k. In this one, what they did is they added k to the first number and then started subtracting. Okay, so they got 3, 3, 6, 8, and the difference between the largest and smallest is 5. So the switch point was actually right here. I mean, we could have used we could have used this as a switch point. Then what would we get? We would get 3, 3, and that would be a 5 and an 8. But the answer would still be the same. This second one also has multiple switch points that would work. But okay, let's get rid of those annotations, and I want to go back to where we can see what we need to see. Just right about there. All right, so we've sorted the array, and we're going to set our initial min to the first element, which in this example is 3, plus k, which is also 3. Let's see. Okay, so k is 3. 3 plus 3 is 6. Okay. You might say, well, how do you know that you want to add k to the first element? I mean, maybe you want to subtract k from the first element. Well, that's not likely because we're trying to bring the smallest element closer to the largest element, and so we don't really want to subtract anything from what is already the smallest element. Now, same thing here is initial max. We're going to take the 20 and we're going to subtract k and say 17. All right, so we know that we can do at least that well. Okay, we can improve, and we're going to take our initial result here. This is the score to beat, which is 20 minus 3, 17. But we know we can do better than that. We can get it down to at least 11. Okay? Now, iterating through the array, starting at 1, which is here, is array at 1, which is 9, minus k, which is 3. Is that less than 0? No. Now, this is just the sanity check for negative tower heights. None of these is going to be negative. Now we're looking for the max possible. The max possible, which is either the initial max or, that is, we're going to look for the max and min possible based on the current switch point between the 3 and the 9. So let's say we add 3 to 3, I minus 1. I is 1, array 0, 3 plus 3, 6. Okay, is that greater than the initial max, which is 17? No. So nothing changes there. This one. What if we start subtracting at array I, which is 1? Then we would have array I is 9, minus 3 is 6. Math min of 6 and 6 is 6. So that is still 6. Actually, I should write max possible. The max possible is 17. And result is the min of result, which is 17, or max minus min, which is 11. So best we can do so far is 11. Go to the next number. Let's see. Array I minus 1 plus k. So the switch point now is between 9 and 12. What is 9 plus 3? It's 12. Is that bigger than 17? No. What is 12 minus 3? 9. Is it less than 6? No. All right. So the result is still the same. Next number, 16. Go through here. 16, we're going to go back to 12. 12 plus 3 is 15. Is that bigger than the max? No. 16 minus 3, is that less than 6? No. And finally, we are at the last number, 20. We'll go through here and say, what is 16 plus k? It's 19. Is that bigger than the initial max? which is 17. And in fact, it is. So we now have a new possible max. I mean, it's not going to help us, but so 19, and then min possible is array I 20 minus 3, 17. So that's still the same. Max minus min down here, 19 minus 6 is 13. We did not improve on our result, so actually the result is still 11, and that's what we got here. So, okay, recapping the strategy, sort the array, and we're going to try to bring the tower heights closer together by increasing the shorter ones, decreasing the taller ones. So we got to split the array at some point where the towers on the left of the split get increased by k and the towers on the right of the split get decreased by k. And because we're trying every split point, we are guaranteed to find the best answer. Let's get rid of this, and we'll try and run it. Whoops, gotta get rid of that. All right, let's try it. Okay, good. So, yeah, please like the video and subscribe to the channel. It's free, and we'll see you next time.